Find the open intervals on which the function is increasing or decreasing. The function is g of x equals sine of x plus cosine of x, and we're looking at the interval 0 to 2 pi. In order to find these intervals on which the function is increasing or decreasing, we need to find the critical values. To find the critical values, we need to find g prime of x, and that is cosine of x minus sine of x. Once we have this information, we can now set it equal to 0 and solve for x, and look for any undefined values of this derivative. The cosine function is defined for all x values as well as the sine function. So this derivative is defined everywhere. That means there are no critical values that we can find where this derivative does not exist. The last thing we need to do is solve this derivative for x. One way you can do that is if you add sine of x to both sides to see that cosine of x equals sine of x. So this is when the coordinates on the unit circle, remember the x coordinate is cosine of x and the y coordinate is the sine of x. This is when the coordinates are exactly the same. This only happens in two places on the unit circle. When the angle measure is pi over 4, and when the angle measure is 5 pi over 4. The coordinates on these points of the unit circle for the angle 5 pi over 4 is negative square root of 2 over 2, comma negative square root of 2 over 2. So the cosine and the sine coordinate are exactly the same. At pi over 4, this is square root of 2 over 2, comma square root of 2 over 2. And again, the cosine and the sine coordinates are exactly the same. So for this equation, we have two answers. X must be pi over 4, and x must be 5 pi over 4. On this next page, I have the derivative we found in the last page, and the critical values. And the critical values are already plotted on a number line. One thing I need to say about this number line is that we restricted our interval to start at 0 and end at 2 pi. So when we are figuring out which intervals are increasing and decreasing, we cannot go past 0. You cannot pick negative pi or negative pi over 2 to help you figure your answer. It has to be a value between 0 and pi over 4. The similar idea over here on the right side of this graph, we cannot pick a number past 2 pi. So you have to pick a test value between 5 pi over 4 and 2 pi. That being said, I'll pick some test values here, ones that are easily computed in a sine and cosine. I want to pick pi over 6. In the middle, I'd like to pick pi, and at the end, I would like to pick 3 pi over 2. And we must evaluate the derivative at all of these test points. If the derivative has a positive value, then we can say that the original function is increasing at that interval. And if a derivative has a negative value, then we can say the original function is decreasing at that interval. So when pi over 6 is substituted in for x into the derivative, this means we need to find the cosine of pi over 6 and subtract the sine of pi over 6. Well, I know the cosine of pi over 6 is the square root of 3 over 2, and the sine of pi over 6 is 1/2. And when you subtract these things, square root of 3 minus 1 over 2, that is something that is positive. That gives you a value that's bigger than 0. So that tells you the original function is increasing on that interval. If you do similar work for the test value pi and the test value 3 pi over 2, you will find that in the middle interval, you will see the derivative is negative, and on the right interval, the derivative at that point is positive, which means that on the original function in the middle interval, it is decreasing, and on the right interval, the original function is increasing. So for the answer of where the function is increasing or decreasing, it is increasing on the interval from 0 to pi over 4, and again it increases on the interval 5 pi over 4 all the way to 2 pi. This interval, or this original function, is decreasing on the interval pi over 4 to 5 pi over 4. For this last page, we need to discuss where the relative mins and the relative maxes occur. The first derivative test states that if a function stops increasing and starts decreasing at a point, then there is a relative maximum at that x value. It also states that if the function stops decreasing and starts increasing, then there is a relative minimum at that x value. And in order to find out what the actual ordered pair is for the relative max or the relative min, we need to substitute the x values back into the original function. So we will look for g of pi over 4, and that is equal to the sine of pi over 4 plus the cosine of pi over 4. What this becomes is the square root of 2 over 2 plus the square root of 2 over 2, which equals 2 square roots of 2 over 2. And what you'll notice is that its 2's cancel, and we are just left with the square root of 2. So when you substitute in pi over 4, you get back square root of 2. So our relative maximum happens at pi over 4 comma square root of 2. And again, if you do some similar work like this in the original function for 5 pi over 4, you will see that the relative minimum happens at 5 pi over 4 comma negative square root of 2. So here are the relative extrema for this function.